So the law of cosines doesn't just happen by accident. It doesn't appear out of nowhere as just a jumble pile of A's and B's and C's and the cosine of an angle thrown in for good measure. Instead, it is an application of the distance formula coupled with some given information that we know about a triangle. Now what we have in front of us here as far as the notes is the worksheet that is part of the assignment. So we're going to go through the first column of that worksheet, the first 3 problems to show where the law of cosines equation comes from. We're going to derive that equation using the worksheet to guide us, and then the second half of the worksheet will be yours to work your way through. So in the diagram here, the assumption is that we know 3 pieces of information. So we're going to say that we know what the length B is, we know what the length C is, and we know the angle that's in between them. So we're going to assume that those are known pieces of information. And so this fits with the law of cosines, since we either can know all 3 sides and have not know one of the angles, or we know 2 sides and the included angle. So in this case, we have the side angle side format. And so what we're going to try to do is we're going to try to figure out, all right, what is the length A? How can I write the length A in terms of these 3 measurements that we know, the 2 lengths B and C and the angle A. So we're going to apply the distance formula to the diagram that we have here. We're going to use the distance formula to find what that length A is. And so A is just the length that travels between the points B and C. And so for the distance formula, if you'll recall, it's D equals the square root of, or if we square both sides, we'd say it's D squared equals the difference between the x coordinates squared added to the difference between the y coordinates squared. Meaning if I know the coordinates of the 2 points, endpoints of this segment labeled with the A there, then we can figure out what its distance is. And so we want to express these coordinates, the coordinates of B and the coordinates of C, in terms of those 3 given pieces of information. So let's start off with the point B right here. So if we take that point there, the horizontal distance that we're traveling is just the length of the bottom of the triangle, which is C. That's our horizontal distance. And then we're not moving up or down, so then our y coordinate is 0. So easy enough for us to figure out what are the coordinates of the point B. A little bit trickier for us are going to be the coordinates of the point C. Now again, we're trying to express it just in terms, the coordinates of that point, just in terms of those 3 pieces of information that we know on the left-hand side of the triangle. And so I need to know what the horizontal distance is to get to that blue line that I've dropped, that perpendicular, and I need to know what that vertical distance is. Well, if we start off, the vertical distance is the height of the triangle. And so we have experience with that. We know how to find the height of a triangle if we know the information that we have in this case. And so the height of the triangle, or the y coordinate in this case, is going to be B times the sine of A. So we know that from our law of sine study, that if we know that hypotenuse of this right triangle after we drop that perpendicular and we know the angle A, that we can write a sine equation, sine equals sine of A equals y over B, or h over B, and so then we can just multiply both sides by B, and then we've got the height. So that's B times the sine of A is our y coordinate. Now the x coordinate is not the length C, because we're not going all the way that horizontal distance like we did to get to the point B. Instead, if we call this distance right here x, right? So x is going to equal B times the cosine of A. And we know that because if we kind of work backwards a little bit, cosine of angle A is going to be adjacent over hypotenuse, which is going to be that horizontal distance x over B. So then again, if we just multiply both sides by B, we get x equals B times the cosine of A. And so now we've successfully described the coordinates of the 2 points that are the endpoints of the length A. And so now we're ready to write the distance formula using those 2 coordinates. And so again, we're just relying on this right here. So d squared is now going to be a squared, since a is the length that we're interested in. So we're going to have a squared equals, And now we need to take the difference between the x-coordinates. Well, my x-coordinates, we can see there, are b cosine A minus c. So there's the difference between the x-coordinates. So we have that squared. And then we have to add to that the difference between the y-coordinate squared, which is going to be b times the sine of A minus 0 squared. And so here's our distance formula that we're going to need to still clean up, but that gives us the length A in terms of the three pieces of information that we know. The length B, the angle A, and the length C. Those are the only three things that appear in any of the parts of the equation that we just wrote. So all I've done now is I've just transferred the equation that we wrote down to the second page, or down the page, and now we're going to simplify. So our end goal is to try to end up with the law of cosines with the a squared isolated. So we can probably write that here so we kind of keep in mind what our target is. A squared equals b squared plus c squared minus 2bc times the cosine of A. This is what we eventually want to turn our equation into. So we can see that we've got the a squared in place. That's taken care of. But the other pieces were a long way from there. So let's see what happens. First thing we're going to do is we're going to FOIL this first set of parentheses. We've got b cosine of A minus c. We of course know that we can't just distribute the exponent. We have to multiply by FOIL. And so if we do that, we're going to get b cosine A times b cosine A. So we're going to get b squared cosine squared A. Let's make that look like a squared there. And then we're going to get a negative c times b cosine A. We're going to get another negative c times b cosine A, which means we're going to end up with negative 2bc cosine of A. And so we can already see an element of our law of cosines appearing right there. And then finally, to finish out the FOIL, we've got negative c times a negative c, which gives us a plus c squared. So there's another element of our final answer that we're looking for. We still have to square the second part of the equation. So we've got the b sine of A minus 0, which is just b sine of A. So fortunately, we don't have to do any full FOIL there. We just have to square b times the sine of A. So b times the sine of A times b times the sine of A is b squared sine squared A. So again, to review, we've got a couple of the elements that we want to see. We've got the plus c squared. We've got the minus 2bc cosine of A. But the piece that we're missing is the b squared. And instead, we have a b squared cosine squared A, and we have a b squared sine squared A. Well, what I'm going to do now is I'm going to rearrange the pieces a little bit. So I'm going to go ahead and rewrite our equation and just kind of regroup things. So I'm going to write it first with b squared sine squared A plus b squared cosine squared A. And then I'm going to write the plus c squared and then the minus 2bc cosine of A. So really now we can see that the challenge that we have is this b sine squared A or b squared sine squared A and this b squared cosine squared A needs to turn into b squared. Now hopefully we're starting to see where this is headed, but if not, what we're going to do is we're going to factor from just this part of the equation. So both pieces, b squared sine squared A and b squared cosine squared A, have a b squared in them. So I'm going to undistribute a b squared. And then left behind is sine squared A plus cosine squared A. And then of course we have the rest of our equation still here, plus c squared minus 2bc cosine of A. And so now we can apply the Pythagorean identity. So in the parentheses, after we factored out the b squared, we have sine squared plus cosine squared. Well, that equals 1. And so that means that we have indeed come up with the law of cosines. B squared plus c squared minus 2b C cosine of A. So what we've shown is that the law of cosines is not just some jumble pile of letters and cosines, but instead is a byproduct of applying the distance formula to one of these oblique triangles using the given information in that side angle side format. And so then, of course, it's by extension that we know that we can, if we know all three sides of a triangle, then we can use the same formula, because then we still end up with just one unknown, which is the angle. So there's the derivation of the law of cosines.